Alright folks, welcome to lesson 2 in chapter 2 of module 1. We are going to go beyond just GCF and DOPS and factoring, doing reverse FOIL or reverse distribution, whichever we want to call it. And we're going to take a look at borrow and payback now and factor by grouping in this chapter, and I'll show you one AC method in class as well. So 3 ways to tackle it. Generally these methods come up when you have a situation, and I'll talk about that in a moment. So let's roll. The situation we're talking about is right up here. When I'm talking about right here, ax squared plus bx plus c has an a bigger than 1. So when there's nothing out in front, you can go with the other 3. We take a look at those methods. As soon as I get a number out in front, you can do the old traditional guess and check and play around with the numbers, but you could be there a while. So we have a couple methods we're going to look at, including in the first one here, borrow and payback method. And as you can see, I've got a 3 out in front here. So I'm going to show you what we're going to do. We're going to first take this 3 and we're going to borrow it. So we're going to put it all the way at the end and multiply it here. So when I tackle that, go. Right, so I take the 3 times the 8 at the end, and so I'll have x squared plus 2x and minus 24. And now it looks like the ones we've been factoring. There is no GCF available. It is a trinomial, so I'll factor in the 2 binomials. So x squared, of course, is x and x. Bring down that plus sign right away right there. The boss right here says, hey, you need different signs, so there we go. Put a minus in there. 24, you got lots of things. 1 and 24, 2 and 12. What else you got? 3 times 8 if we go in order, 4 times 6, that's all of them. With boss says we need the pair that subtracts the 2, so that's the 4 and 6. Put the 6 in, put the 4 in, and you factor it. So the original part up here is called the borrow, but now we got to do the payback, because if I go and multiply these, do tabular or whatever, the solution right here, this is not going to give me what I started with right away. X times x is x squared. I've got to get a 3x squared. So we're going to reinsert the 3 here and here. And what happens is we actually overpay it with this method. So I'm going to reinsert it. I'll change color and I'll show you. I'll put a 3 in right there and a 3 in right there. Okay. And then you got to turn around and say, okay, what goes into both of these? Well, obviously, here's the GCF. They both 3 goes into both of those. Nothing here. Well, I overpaid by 2 3s, so if I can get one of the 3s out of there, we'll be good. And that's what I'm going to do here. So I'm going to sweep that away and just call that x plus 2. The 3 disappeared. I basically divided both by 3. And I kind of slide the 3 under the carpet. I just get rid of it because I overpaid. The other one's called 3x minus 4. There was nothing in common there. And guess what? If I do a check here, this will work, and you will get right away your 3x squared, and then you'll get a minus 4x and a plus 6, which is a positive 2x, and then 2 times negative 4 is negative 8, and that's what I have up there. Okay, that's your borrow and payback method. So we're going to go and try another one of these. So let's move on to the next one. Okay, in example 2, I will do borrow and payback again. I will throw the 15 at the end, which means now I have y squared minus y, and 15 times 2 is 30. I turn around and factor it. There is no GCF there. We get y and y. Once again, I bring down that first sign right here. Bring it down, so that's a minus. The other guy here, the boss here, says you got a different sign, so this guy has to be a plus. I've got the 30 here, which factors into 1 and 30. You've got 2 times 15, you got 3 and 10, and 4 does not work. 5 and 6 gives me all my pairs. The boss here says I need the pair that subtracts to an unwritten 1 right there, so it's going to be the 5 and 6. Put the bigger one first, and we have factored it. However, of course, we borrowed the 15 way back here in the beginning, but we got to pay it back, so you got to reinsert the 15 in both places. Okay? I cannot factor out this time a solid 15 because I've overpaid by 15. I can't take out a 15 on both of those and 15 on both of those. So this is the case where they'll actually get split. In this case right here, what can come out of 15 and 6? Well, they share a 3. So I take the 3 out of both. If you want, you divide them both by 3, and I'm left with 5y minus 2. And on the other one, if I got 3, what times 3 gives me 15? Of course, 5. So 5 comes out. So there's your 15, a 3 and a 5, a combination of things. So when I do that, I get 3y plus 1 when I divide by 5. And if you do the check real quick, 5y times 3y gives me 15y squared. I get a outside of 5y, inside of minus 6, which gives me a minus 1. And then, of course, minus 2 times 1 is a minus 2. And that's borrow and payback. We're going to do a few more in class, but that's just reviewing that method. Let's move on to one other type right now. It's called factor by grouping. Down to question 6. Okay, factor by grouping is very similar to, we did it back in algebra. It's basically taking a look at two things. I want to look at right here, the first two, kind of group them that way, and I want to group them this way. So I want to show you here. I'm going to group this pair right here. I'm going to go group this pair right here. And all you really do on the grouping now is pull out the GCF. So they don't share, this pair right here does not share a number. However, they both do share what? An x. So we can pull out an x, actually two x's here, and pull out an x squared. So on that one there, I'm going to pull that out, put an x squared out in front, and what's left? The 3 and one of the x's plus 5. And what you'll notice now is on the other one, chances are we have to have the same 3x plus 5 in the other one. So what happens over here? Well, what do they share right here? Well, they both share a 4. They both share a minus sign. So I'm going to pull that out. So a minus and a 4 come out. Okay? So I'm really dividing by minus 4, dividing by minus 4 if you're really looking at it that way. And what's left? A 3 and an x. And if the minus sign comes out here, okay, this comes out, that goes in there 5 times. So if I take a look at that, that's a 5, so plus 5. And now what you'll notice is they both share that 3x plus 5, which we did back in 9th grade, and we have a common binomial right here. So that is one of your factors. So I put 3x plus 5 as one of my factors. And then the stuff that's left I didn't use here, that's outside, the x squared and the minus 4, is the other factor. You put it all back together. Now normally I'd say you're done, but does anybody notice what's going on right here? What's this? Yes, difference of two perfect squares, so we are not done. 3x plus 5 is fine. That's one thing, but now I can bust up the x squared minus 1, x squared minus 4 into x plus 2 and x minus 2. And there's your answer. If you multiply the 3 of those back together, you'll get there. There's nothing else I can factor out. Okay? That's called factored by grouping. We're going to take a look at one more of these just in the video, and of course we'll practice in class tomorrow. Alright, so our last one, once again, we're going to take the first two and group them, and we're going to take the last two and we're going to group them, and we're going to go and factor here. Well, what do they share up here? Well, if you take a look at this one here and this one, you can see they share two x's, and also the number 2 goes in there. So I'm going to pull out a 2 and an x squared. When I divide that by 2x squared, I'm left with 3x plus, take that out by 2x squared, and you're left with a 2. Then the second part, you will notice they share a minus sign again, and they also share a 3. So we're going to pull that out. So a minus 3. And what's left when I divide by minus 3? Well, I'm left with a 3x. And when I divide a minus 6 by minus 3, I am left with a positive 2. So, once again, they are sharing a common piece. So 3x plus 2 is one of your factors. The other one is called 2x squared minus 3. Those are the pieces that you didn't use yet. So we put them together right there. This here, of course, is a perfect square when you're looking at the x squared, but 2 isn't. I do have a different sign, and nor is 3. So bottom line is, we can't factor this anymore, we can't factor that anymore, so that is your answer. Okay? So if you need to watch this again to get the hang of those two, try a couple out of your packet, that's fine, to see if you can get a head start on it, and I'll see you in class.